All right, so to compute this one, first you want to find a row or column that has the most zeros. So that would probably be the fourth column here. Okay, because it's got 3 zeros, so that looks good to me. So let's see. So let's write down the checkerboard. Checkerboard looks like plus, minus, plus, minus, minus, plus, minus, plus, plus, minus, plus, minus, minus, plus, minus, plus. Okay. So that means that if I'm starting with a fourth column, the first one here is going to be a minus. So first one's going to be a minus. I'm going to have minus 0 times the determinant of something. So I don't care about that. And I'm going to get plus 0 times the determinant of something. So I don't need to write that down. When you do this, you don't even need to write down these 0 terms. I'm just showing you where they come from. And this term here gives me minus 0 times the determinant of something. And then this last term here gives me plus 4 times the determinant. Now, this is the determinant of what? This is going to be the determinant of the 3 by 3 obtained by crossing out this and this. So that's going to be 1, 1, 0, 1, 0, 2, 0, 1, 3. Okay. All right, so let's go ahead and we'll call this B. So let's find the determinant of B. Let's just go ahead and do this on the first row. Okay. So first row is going to give me, I know that the first row starts with a plus, so that's going to be a plus 1 times the determinant. Now, what the determinant here is going to be the determinant of this row and column thing where you cut that out, and you're just going to get what's here. So that's going to be 0, 2, 1, 3. So that's the first one. And then I have a minus, and I'm going to the first row, so I'm going to have minus 1 times the determinant. And then here I've got, I'm going to cross this one out, and that leaves me 1, 2, 0, 3. Like that. Okay. Now this determinant, you should know the determinant of a 2 by 2. Determinant of a 2 by 2 is just AD minus BC, like this. So this determinant of this 2 by 2 is going to be 0 times 3 minus 1 times 2. So this is minus 2. And this determinant here is 1 times 3 minus 0 times 2. So this is going to be 3. So I have minus 2 minus 3. So that's going to give me minus 5. Okay. So determinant of B is minus 5. So determinant of A, if I go back up here, determinant of A is 4 times determinant of B. It's 4 times minus 5 is equal to minus 20. Okay. Now I'm too scared to check it, but anyway, I got the method is right. All right. So that kind of method, you just break things down, alternate the rows, alternate the terms, and do it like that. Maybe I can just make up a 3 by 3. Or I'll look in the exercises that we got. Let's go back and see what else we need to do here. Okay. All right. So let's see. Okay. Elementary matrices, I should say something like that. All right. How about I do this one? Compute the 4 by 4 elementary matrix. Boy, I made a lot of mistakes here. So this should be matrix. Let me edit it. Let me just fix it now. This one should be 1, 2, 3, 4. All right, this one here is 4 by 4 elementary matrix. Okay. All right. So let me just go ahead and grab this while I'm here. I'll go to my OneNote, and then we'll go here. Okay. All right. So the thing about elementary matrix, so the elementary matrix, this is obtained by applying, bless you, the given row operation to the identity. So the idea is very simple. If I give you a row operation, you apply that row operation to the identity, and that gives you the elementary matrix. That's all there is to this. Okay, so if here we multiply row 2 by minus 7, that means I take the identity here, and then I'm going to apply row 2 times minus, so I'm going to do minus 7 R2 plus R4. I'm sorry, not 4R4, just R4 plus R4. And I apply that, and I get my result. So I'm just going to get 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0. And then the last one is minus 7 times R2, so I'm going to get minus 7 times 0 plus 0, 0. Minus 7 times 1 plus 0 is minus 7. Minus 7 times 0 plus 0, 0. And then here, minus 7 times 0 plus 1 is 1. Okay? So that's my result. Now notice that the determinant, if I call this A, the determinant of A is equal to what? Well, we could do our row expansion thing. All right. We might as well do, say, the first row. So I'm not even going to write down the zeros. If I expand upon the first row, I'm going to get 1 times the determinant of the smaller matrix, which is 1, 0, 0. Smaller matrix being this one here. Smaller matrix is this guy here. 1, 0, 0, 0, 1, 0. And then minus 7, 0, 1. Okay. Then I can go ahead and do another row expansion on this one. So that's equal to, so I've got a 1 here, so I just got 1, and then I'll get is 1 times determinant. And then here I'm going to take the 2 by 2 formed by this one here, which is 1, 0, 0, 1. So that's it. The result is equal to 1. And the result that you'll see talked about in the chapter is the determinant. Let's see. So let's see. So if I take the multiply and add, that means that the determinant of the elementary matrix determinant. Let me just write it this way. The determinant of the corresponding elementary matrix will be equal to 0. Equal to 1. If I just take multiply row, that means that the determinant of the elementary matrix for that one is equal to, here let me say multiply row by A. If I take that, the determinant of the elementary matrix is going to be A. And if I hear this one, if I swap rows, then that means that the determinant of the elementary matrix is equal to minus 1. All right, so those are the rules for determinants of elementary matrices. And you can prove that using your regular determinant operations. All right, so let's see what else we want to do here. So that's fine, that's fine. Okay, here say watch this, watch this, watch this. Look at practice exercises. Let's see. Oh, this is for 4.5. We're looking at 4.3 today. So more examples of determinants, elementary matrices. You can also think about the following questions and so on. So let's see what else we have on the outline. Let's see what I can. All right, so let's go ahead and save this. And I'll go back to the, let's see, let's go back to the syllabus page. And I can open up the course outline, I suppose. And here we are. And let's look for determinants. It didn't go there, so let's do it again. All right, so compute this one, this one, this one. Find missing values in the matrix to determine the matrix is 0. All right, so this is a good one. Let me make up another one for this, for competency 3, because actually this comes in later in a very important way. So let me do one of these. Okay. So I'll say find x such that the determinant of 3 plus x, and here I'll do 0, 0, and then 4, and then this is going to be 7 minus x, 2, and then it's going to be 2, and then, let's see, I won't make it up, 9, 2 minus x is equal to 0. Okay? Ashley, you still with me? Okay. All right, so let me just go ahead and do this. Actually, instead of plus x, let me make that a minus. Because it usually is a minus. I'll do minus 3 minus x. How about that? Minus 3 minus x. All right, so we'll do that. All right, so let's go ahead and do the determinant here. Let's expand on the first row. So if we call this A, then we have determinant of A, whoops, is going to equal minus 3 minus x times the determinant. Well, I have to take the determinant of the smaller matrix. Smaller matrix is this one here. This 2 by 2 matrix here, right? If I cross out the first row and first column, I'm going to get 7 minus x, 2, 9, 2 minus x. All right, now, you should remember the determinant of a 2 by 2 is just going to be, so I'll just write here again, determinant of A, B, C, D equals AD minus BC. Right. So this is going to be 7 minus x. So let me leave the minus 3 minus x in there. It's minus 3 minus x. And then it's going to be 7 minus x. And this is all times this. 7 minus x times 2 minus x time minus 18. All right. So let me write out again here. Minus 3 minus x times 7 minus x, 2 minus x, minus 18. Okay. And so now I have to do this one out. All right. Now the best way to do this is look for powers. By powers here, I'm going to have some terms with x squared, some terms with x, and some terms with a constant. So the terms with x squared is going to be minus x here, minus x. It gives me x squared. The terms with x are going to be minus 2x, minus 7x, so that's minus 9x. And the constant terms are going to be 14 from here, minus 18, so that's minus 4. So here I have minus 3 minus x times x squared minus 9x minus 4 is equal to 0. This is because I was told that the determinant is equal to 0. So let me keep this as 0. All right. So my solution is, I get one solution from here, right? If I have the product of two numbers are 0, then either one is 0 or the other is 0. So this one gives me a solution, x equals negative 3. So that's one solution. Now I need a solution from here. This one is just your old quadratic formula, 9 plus or minus square root of b squared is 81 minus 4ac, which is plus 16, over 2a. All right, this one's kind of messy, but it's going to be equal to 9 plus or minus, let's see, 87, 97. Okay, so that gets me, let's see, 9 plus 97 is 106 over 2. 106 over 2 is 53. No, I'm sorry, this is square root. Can't do that. Square root. All right. So that doesn't simplify. That's as far as you can go. So here you get x equals, so there are three possible solutions for x. You get x equal minus 3, x equal 9 plus or minus root 97 over 2. So that's my answer. Okay? I'm doing this pretty fast because you can pause the video, go back and check check my work. But I don't think I made any error. And let me see if there's anything else I'm going to do. No, it looks like this is pretty straightforward this week. Yeah. So here all right. That's actually for this one's actually for Thursday. So this one is more just the mechanical skill of getting the determinant. So I hope by the end of this week, everyone will be able to compute determinants very easily. So I think that's all I wanted to say. Let me pause my video